So let's go ahead. Let's do an example here. Okay, so we're going to find dy dx if x cubed plus y cubed equals 18xy. Okay, so we want to find dy dx. So let's start off with x cubed plus y cubed equals 18xy. Okay, so we're going to differentiate both sides with respect to x. Now I'm going to do a step in here that, or a part of this that later we'll probably take out, but to hopefully get you to understand what it means to take the derivative with respect to a variable. So when we take the derivative of this equation with respect to x, we're actually doing a bunch of chain rules. We just never really wrote it down, because until recently we didn't even know what the chain rule was. So, for example, the derivative of x cubed, we do have an inside part which is x and an outside part which is the cubed. So the derivative would be 3x squared times the derivative of the thing inside. Well, the derivative of x is dx dx. Now, we don't write that down because what ends up happening is dx dx is 1. Okay. But then when we get to this one here with the y cubed, we do the same thing. The derivative of y cubed is 3y squared, and then we take the derivative of the thing inside with respect to x, dy dx. Okay, so over here we have an 18. Now, you have to make a decision. Either this 18 has to go with one of the functions, or you put the 18 out front like I'm going to do here, and then we'll take the derivative of this with inside these parentheses. And so I'm going to do the second option. Now remember, this is a product, x times y. So we got to take the derivative of that product. So we have the first, x, times the derivative of the second. Well, the derivative of y is 1, but we also have the derivative thing inside, which is dy dx. Then we have the second, y, times the derivative of the first, which is 1 times dx dx. Okay. So we've taken the derivative with respect to x, and one thing to note is that all these dx dx's, as I said earlier, well, they're just going to go to 1. So this is going to go to 1, and this is going to go to 1. So now we have 3x squared plus 3y squared dy dx equals, and then I'm going to go ahead and distribute this 18. 18x dy dx plus 18y. Okay. Let's see. Now this is just to clean it up a little bit. I notice that there's, we have 3, 3, 18, 18. I'm going to multiply everything by 1/3 just to clean it up a little bit. So we have x squared plus y squared dy dx equals 18x dy dx plus 18y. Okay, Now the next thing we want to do, according to our rules, is we're going to place all the dy dx terms on one side and the other terms on the other. So let's go ahead and do that. We end up having, let's see, so here's a dy dx term. So we're going to have y squared dy dx. And here's a dy dx term, so minus 18x dy dx equals, and then we have 18y minus x squared. So for this part here, I mean, basically we took these two terms and put them on one side and these two terms and put it on the other. That's all that is. Okay, I need another piece of paper here. All right, the next part of this is we need to factor out dy dx. So let's see if I can fit this in here. So when we factor out dy dx, we get the following. Dy dx times y squared minus 18x equals 18y minus x squared. Okay, then the last thing we need to do is solve for dy dx. So we're going to divide each side by y squared minus 18x. So we're going to end up with dy dx equals 18y minus x squared all over y squared. You know what? I made a little mistake back here, didn't I? When I multiplied by the 3, I forgot to make these 6's. So this should be a 6, 6, 6. So that means this should be minus 6x. So let me rewrite that again. Dy dx equals 6y minus x squared all over y squared minus 6x. There we go. And there's our final answer. Okay, so there are the steps of finding a derivative implicitly. And when we do that, we take the derivatives with respect to x. We place all dy dx terms on one side and everything else on the other. We factor out dy dx and we solve for dy dx.